Happy Friday. So today we're going to review solving by factoring, but we're also going to look at cases where factoring doesn't work. And in fact, that is the majority of cases because factoring rarely works. So we're going to explore today the quadratic formula. First, let's solve through factoring. So here is a quadratic equation, and I'm using f of x, so I'm using function notation to ask a question. I'm saying I want to know what x is when f of x is equal to 6. All right, well, I'm going to substitute in 6 for f of x, so I'm going to substitute in 6 for y. So I'm going to go 6 is equal to 45x squared minus 141x plus 90. And I know that solving through factoring only works if one side is equal to 0. So I'll have to make this left side 0, and I can do that by subtracting 6, but whatever I do to one side, I have to do to the other. And this is going to be 0 is equal to 45x squared minus 141x, 90 minus 6 plus 84. And now I want to know if there's any GCF. So now I can actually go ahead and start to factor. So I'm looking for my greatest common factor, and I do have one. I have a greatest common factor of, 45, 141, and 84. Those are all divisible by 3. So I'm going to have 15x squared minus 47x plus 28. Now that I've removed a GCF, I can now see if this is factorable. So I'm going to be looking for factors of 15, 28. So this is a complex trinomial. So let's do our decomposition here. So let's meddle with the middle. So I'm looking for 2 values plus 28. So I'm looking for 2 numbers that will multiply to the product of the first and last terms. So I'm looking for 2 numbers that multiply to 420 and that add to negative 47. Let's say, so negative 12 and negative 35. I know they both have to be negative because they need to add to a negative number, but then they need to multiply to a positive number. So negative 12 and negative 35. So you're going to have 15x squared minus 12x minus 35x plus 28. All right. And I'm going to factor this by grouping. So I'm going to take the 15x squared minus 12x, I'll put those in a group, plus negative 35x plus 28. There we go. 0 is equal to 3, and I'm going to factor out what I can out of both. So this is going to be 3x, and I'm left with 5x minus 4. And then out of here, I'm going to factor out, so 35, and so this was 3x, and out of here, I'm going to have 7, negative 7. And I do like to pull out the negative 7 only because I like it to be, I like this first term to be positive. So that's going to give me positive 5x plus, minus rather, because I'm pulling out a negative 7, minus 4. Minus 4. All right, perfect. That works out because these two are the same, which is my requirement for factoring by grouping. So that's how I know that this is factorable. And so I'm going to pull those out, and I get 0 is equal to 3, 5x minus 4, and 3x minus 7. And that's great. I was able to factor this, but that's not really what the question is asking. The question is asking for me to solve, which means they're asking for me to find the values of x for which y is 6. And I can do that now because I've got it in a more manageable form. And all I have to do is either get this binomial to equal 0 or this binomial to equal 0, and I'm good. So I know that my solutions will therefore be, it will either be x is equal to, so my rule is negative, the opposite sign will be of the constant will be the numerator divided by the coefficient, so 4 over 5, or in this one, it would be positive 7 over 3. So those are my two possible solutions. Those are the two x values when y is 6. And that's great. That uses all of the skills that we've learned so far, decomposition, factoring, greatest common factor, and solving by factoring. But to be honest with you, the only reason we can factor that is because I have created a quadratic that's in the minority of quadratics. So it's in the 0.1 percentile of quadratic functions that are actually factorable. Most quadratics that we come across are not factorable. If I were to come up with a quadratic equation, let's just make one up. Let's say that we have f of x is equal to, I don't know, 5x squared minus 13x plus 11. And I were to say, I want to know what the x is when the y is 2. Well, to be honest with you, this is probably not factorable. It probably doesn't come out to a rational number as a solution. It probably comes out to an irrational number. And if it's coming out to an irrational number, it is probably not something that is factorable. And if we were to graph this on Desmos, we will see that the point where y is equal to 2 is probably a giant decimal number in terms of x. So we contrive these questions. We make them up. We make them up so that they work properly. But are they useful? Is factoring useful? It's useful in the sense that it helps us understand the foundations of how factoring works and how solving works, but it doesn't work with most of the equations that we come across. So we need a tool that will help us to solve all of these other quadratics, the 99.9% of quadratics that are not factorable. And we do have a system for that, and it is called the quadratic formula. So let's use quadratic formula. There is a video down below in the links, so feel free to check it out. It's just a little musical song, and if you want to know how to memorize the quadratic formula, it is pretty effective. But this is the one thing that you'll remember for the rest of your math career, because you're going to see this every single year, and it's going to be drilled into your head until you don't want to hear it anymore. But the quadratic formula is an x. If you are solving for an x value, the x value is negative b plus or minus the square root of b squared minus 4ac all over 2a. What that means is, if you have a quadratic in the form f of x is equal to a x squared plus bx plus c, so that is a quadratic in standard form. This b is this b right there. This b is also this b right here. This a value is this a value here, and then this c value here is the c value right here. So we look at the quadratic formula or the quadratic equation in standard form, we pull out the coefficients and the constant, and we use those in the quadratic formula to determine what x would be for a certain y value. Now, the quadratic formula only works just like factoring to solve. The quadratic formula only works when the equation is equal to 0. So that is very important. It only works when the equation is set to 0. So just like when we were solving through factoring, we have to make sure that the equation equals 0. Important. Okay, so let's check out what was the equation that I came up with. 5, negative 13, and 11. So 5, negative 13, and 11. 5, negative 13, x, and 11. And what did I want? I wanted to know what the x value and y was when f of x was 2. Okay, so I'm going to substitute 2 into the equation. 2 is equal to 5x squared minus 13x plus 11. My criteria is that the equation equals 0, so I'm going to subtract 2 from both sides. And I'm going to get 0 on this side is equal to 5x squared minus 13x plus 9. Great. So now I can take that and I can plug it into the quadratic formula. So draw it here, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you think it's weird that there's a plus and minus here, it is, but it's like that because for most solutions, because we're dealing with parabolas, most solutions, unless there's no solution or there's only one, all the rest of our solutions are going to have 2 possible answers. Here, if I'm looking for y is equal to 3, for example, what the x value is, I'm going to have 2 possible answers, and this plus or minus is built in because that's going to help us get 2 distinct x values for a y value. So this is my equation set to 0 for when y is equal to 2. So I'm going to plug everything in that I have. So x is equal to, what's my b? So negative, I'm going to sub my b in. And be careful, my b value here is negative. This negative is not connected to the negative of the 13. So I need to make sure that in this substitution bracket, I'm actually putting in negative 13. Plus or minus the square root of b squared, so negative 13 squared. And I always like to substitute numbers in brackets because it helps to keep the signs contained and makes everything nice and clear. The a value is a, the c value is 9, all over 2a. All over 2a, and the a value is 5. Okay, this is going to be the negative of a negative. This is sort of like a negative 1 in front. Negative 1 times negative 13, that's just going to give me positive 13. So I can change that sign, plus or minus. All right, let's do what's in the radical sign here. So we have negative 13 squared. Negative 13 squared, we're going to do this, and then we're going to do, it's up to you whether you keep the negative with the 4 as you multiply or you leave it there. I like to bring the negative with me. So I'm going to bring this negative with me in my multiplication, and then the resulting sign is going to be what I put in as the operator. So follow me if you can. So negative 13. So 13 times 13 is 169. Negative times a negative is a positive, so 169. And then negative 4 times 5. So negative 4 times 5 times 9, so 20 times 9. So we're going to get, this is negative times a positive, so the resulting net operator is going to be a negative. So I got negative 180 all over 2 times 5, which is 10. Okay, so this is, the radical sign is sort of like a bracket, so I'm going to continue working with what's in here. So I have 169 minus 180, so that's going to give me a negative 11. So x is equal to 13 plus or minus the square root of negative 11 over 10. And I have a bit of a problem here in that I can't take the square root of a negative number. I can't possibly take the square root of a negative 11. There's no solution for that. So I can't go any further. And what this is really saying is, if I can't go any further and I can't take the square root of a negative number, then there is probably no solutions to our problem. And if we graph it, all right, so here's our equation. I've just graphed it into Desmos. I'm going to graph it, and we were looking for the for the x values when y is equal to 2. And as we can see here, let me just draw the line at y is equal to 2. There is no solutions at y is equal to 2 because this particular parabola doesn't actually hit at y is equal to 2. So let's actually do one that will work. Let's do y is equal to 4 because I know the parabola does hit at 4. So y is equal to 4. Let's restart. All right, what was our equation? It was 5x squared minus 13x plus 11. Yep. And we're going to look for a solution at f of x is equal to 4. So this is f of x is equal to, I'm going to sub in 4 for f of x, so that's going to give me 4 is equal to 5x squared minus 13x plus 11, and I'm going to subtract 4 from both sides. So I'm going to get 0 is equal to 5x squared minus 13x, and it's going to give me plus 7. And this isn't factorable, so let's work on using our quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal, so b is negative 13. Don't forget that negative has to stay in there. Plus or minus the square root of negative 13 squared minus 4 times 5 times 7 over 2 times 5. X is equal to, is going to be positive 13 plus or minus the square root of, is going to give me positive 169. I take this negative with me for negative 4 times 5, so it's going to be negative 20 times 7. So 20, 40, 60, 120 plus another 20, so negative 140. And we have over 10. And all right, continue on. X is equal to 13 plus or minus the square root of. Now, 169 minus 140, I can do that. That's going to give me 29 over 10. Now, I have to do two things. I'm going to do 13 plus the square root of 29 over 10, and I'm going to do 13 minus the square root of 29 over 10. So let's do one over here and one over here. So this is going to be 13. I'm going to choose to do the positive because this is a plus or minus. 13 plus the square root of 29 over 10. And this is going to be 13 minus the square root of 29 over 10. And that makes sense because when we're looking at our graphs, we know that in Desmos there are going to be two solutions at y is equal to 2, or y is equal to 4 rather. We're going to have a solution here, and we're going to have a solution here. All right, so x is equal to, and you can just do this on your calculator, because I don't know the square root of 29. So 13 minus, and then I can use brackets, the square root of 29 equals divided by 10. Do this in one fell swoop, equals 0.761, where x is equal to 13 minus the square root of 29 divided by 10 equals sorry, I did it the wrong way. This is 0.761, and this is with the addition, and it's going to give me 1.839 rounded. Let's double check that with Desmos. Yeah, pretty good. So that's with solutions. We talked about a situation where there wouldn't be any solutions. The only other situation you have to deal with is if we're actually looking at the actual vertex. So if we land on the vertex, if we're looking for a certain y value and it just happens to be at the vertex, that means there's only going to be one solution. I'll let you sort of explore that yourself, but something funny is going to happen inside the square root or inside the radical that is going to make it so that it doesn't matter whether we add or subtract what's in here, it ends up being the same thing. And you're going to see that it's only going to come up with a solution, but you'll come across this in the homework, so I'll let you sort of handle that on your own. And that's it for quadratic formula. And enjoy your Friday, get some rest, due dates are Sunday, and I will talk to you guys on Monday. If you have any questions or you need any help with anything, DM me. I'm around all weekend, so I can always give some one-on-one help if you want. And I'll talk to you guys soon.